Okay, we have here another interesting integral. I've got the integral of x times e to the minus x dx. And I've already done a couple videos on this that were really similar. I think I've done x times e to the x and x times sine x. And what I want to do for this is I want to do integration by parts. And normally what we want to do is differentiate x because it's going to make our life easy. But I want to make our life harder, so I'm going to integrate x and differentiate e to the minus x. So doing this, I'm going to create a whole bunch of columns for our DI table, and we're just going to switch the signs up, plus minus, all the way down. When we differentiate e to the minus x, we're going to have a minus come out and we get minus e to the minus x. But when we do it again, the minus is going to cancel and we're back to e to minus x. So this is just going to switch off like this all the way down. Notice how much trouble I have just keeping a straight line, but that's not important right now. So what I'm going to do, we'll integrate this. We get x squared over 2. Integrating again, I get x cubed over 6, but I'm going to write this as 3 factorial. And I didn't really give myself enough space, but the next one's going to be x to the 4th over 4 factorial. And this is going to just keep going like this, on and on. And then even though we don't get any resolution to this, but this is just going to go on forever, this is never going to resolve to anything, and e to the minus x just persists over and over. I'm just going to kind of copy down what I can of the solution and see if we can find a pattern. So just starting, what I'm going to do, let's factor an e to the minus x out of all these. So then for our first term, we're going to have our x squared. I'm going to write this as 2 factorial here. Then for our next one, notice we have minus, that's going to become a plus, and we're going to have x cubed times 3 factorial. And then I'm not really lining up very well, but this is going to be x to the 4th. Just going all the way down, you notice the minuses are always going to cancel, so everything's going to be positive, and this is going to go on like this forever and ever. But now at this point, we're kind of stuck, right? Because we got this infinite expression that we don't know what to do with. And the key takeaway here is what we need to do is recognize the similarity of this to the power series for e to the x. Okay, so we have our power series for e to the x down here towards the bottom. And the thing we want to notice, really similar to this, but it just starts at x squared. So what we have here is the same thing as everything we have here going off to infinity. Now, of course, we don't have this piece right here, but this is going to be pretty easy to deal with. So what I can do is rewrite this. We'll still have our e to the minus x up front. This piece is going to be just e to the x. And then I'll just subtract off this 1 plus x. That's going to be minus x minus 1. And so even though doing it this way is definitely slower, all I need to do now is just multiply this in order to finish this off. So e to the minus x times e to the x is 1. Then for this next term, we get minus x e to the minus x. And then for the last one, we just get a minus e to the minus x plus c. And get ready to circle it. And then just circle it. Wait. Actually, before I circle it, what's this 1 doing here? 1's just a constant value when we have plus c for that. So what I can do is just remove this. That's going to get absorbed by our constant. And so now I can just circle it. So that's it. We'll stop it there. Thanks everyone for watching. Have a great day.